this measurement measures 11 centimeters, and this one measures 18 centimeters. Now that's not the point. The point is that it's not this side that I'm measuring, or this side, because this would be undefined and this would be 0. So that's why I choose this slope to measure. And when I do, I get 65 degrees.
These two lines are perpendicular because the angle of this one is 90 degrees and this one is also 90 degrees, making them perpendicular to each other. They are right angles. Check out that bed. This is the two parallel lines that we use to find transversal, and this is also the transversal. When we measure this angle, it comes out to be 45 degrees, and with it needing to be a complete 180 degrees to be a straight line, we just subtract 45 from 180 and we get 135. So now we find that these two are corresponding because they're on the same side and same position. And also these, if it continues down, these two would be corresponding. And also on the same side interior would be these and these because they're both inside and not outside. And also alternate interior angles would be these two angles are alternate interior because they're on opposite sides and they're both on the inside.
And we chose to use a rectangle and cut it in half to make a triangle. The height of the triangle we chose is measured 11 centimeters and the base is 12 centimeters, 12.5 centimeters. The height is 11 and we divided it by 2, which equals 5.5, and we multiplied it by 12.5 and it equals 68.75 centimeters squared.
This is the object we chose as a rhombus.
The measurements are 11.5 centimeters all around. The base is 11.5 times the height, which is 11.5, and that equals 132.25 centimeters squared. The length is 28.2 and the width is 22.1.
And the formula for finding the area of a rectangle is length times width. So we do 22.1 times 28.2, and that equals 623.22 centimeters. We chose for a trapezoid. The length of the side is 4.5. The length of the top base is 4.5. The other side is also 4.5, and then the length of the second base is 7, and then the height is 4.5. So it is base 1 plus base 2 times the height divided by 2. So we do 4.5, which is the first base, plus 7, which is the second base, equals 11.5. And then we do 11.5 times 4.5, which is a height, and that equals 51.75. And then we divide that by 2, and that gives us 28.25. 25.
It is 10 centimeters, and the second one is 16 centimeters. The area of the kite is diagonal 1 times diagonal 2 divided by 2. So, since diagonal 1 is 10, we use 10 times the diagonal 2, which would be 16. So 10 times 16 is 160, and 160 divided by 2 equals 80 centimeters.
squared.
These are the two objects we chose for reflection. This is the original object. If we put a mirror on the y-axis, the original object will reflect on the second quadrant.
Two objects that we chose to use and show translation. This translation is a vertical translation because it's going up and down. So this object slides down and becomes this object because it is translation, and it's not using any other way like rotation or reflection to show that they are congruent. They use translation.
Triangle to confirm that the Pythagorean theorem works. The measurements are 21.5 centimeters and 18.2 centimeters.
Okay, so to solve it, squared plus b squared equals c squared. So you do 21.5 squared plus 18.2 squared equals c squared. So 21.5 squared plus 18.2 squared equals 793.49. And then you take the square root of that. And, and that equals 28.16.
We chose to find a mid-segment that is half of the base. This is the base, and for centimeters, when we measure the centimeters, it's 10.5 for the middle and 21 for the whole complete base. So we take 21 divided by 2 and find that 10.5 is the mid-segment. We are using, and we're also using cosine to find out the hypotenuse. In centimeters, the length of this side is 25.5 centimeters, and the angle of this side measures 35 degrees, and this angle measures 90 degrees, which makes it a right triangle.
The formula for cosine is adjacent over hypotenuse. Cosine 35 degrees equals 25.5 over x. In order to have x alone, we divide cosine and you bring it over, so it's 25.5 over cosine 35, and it equals 31.12.
We're trying to find sine. The angle degree of this angle is 90 degrees. This one is 50 degrees. And the length of the opposite side is 26 centimeters.
So the formula for sin is opposite over hypotenuse. And so we're going to take sin 50 equals 26 over x. And when you want to isolate the x, you go x times sin 50 equals 26. And now you want to isolate the x further, so you divide it by sin 50. And that equals to 33.94.
This is our triangle for tangent. We took a rectangle and then we just split it in half. So, the triangle. Okay. The length of this side is 6.7. It is 55 degrees, and then this one is 90 degrees. And then we're trying to find the height.
Okay. So we're going to use the tangent. And when we use tangent, we use opposite over hypotenuse, over adjacent. And we know that this is adjacent because we have already this angle degree. So we go across from there, and that's x, which is opposite. And so what's left is adjacent. So the formula is opposite over adjacent, and then we use the degree, 55 degrees. Tangent 55 degrees equals x over 6.7. Okay, so then we're trying to get x to be alone, so then you multiply it by 6.7. So that's going to go on this side, which will also end up here. So it's 6.7 times tangent of 55 degrees, which would equal x. So we'll plug that in. We go 6.7 times tangent 55 equals... Wait, I think it's because I don't have it on degree. Now let's try it again. 6.7 times tangent 55. That's more like it. It's 9.56. That'd be centimeters.
We're trying to find the arc cosine.
Brayden!
So the measurement
I got paper. Oh!
is 16. The adjacent side is 16.5, and the hypotenuse is 20. So you type into the calculator. Second cosine, so arc cosine, we do 16.5 because cosine is adjacent over hypotenuse, so 16.5 divided by, for the adjacent side is 34 degrees.